Good morning and welcome to a new Microsoft Reactor London event. Today we will talk about how you can start your own IoT projects. My name is Christopher Manner. I'm a startup cloud advocate and I'm a developer and I've been developing embedded and IoT system for the last 10 years. And today we will see how you can create your own IoT project, even if you don't know how to solder anything, or even if you don't know how to code. So the only thing you need to get started for this session is just a bunch of ID. So let's get started with a little introduction. First, you will have access to all the slides, and some of my demos are already recorded online. So you will have access to all this content just after the session. So why thinking about IoT project when you're in a startup environment? The fact is, there is a huge opportunity regarding to IoT space. Uh, in the last year, we doubled the market size for IoT. I don't have any precise numbers because the numbers are computed by some organization, and it's kind of difficult to grasp an exact numbers, but it's definitely in hundreds of billions dollars revenue for company around IoT startups. And it's not the only specifics about the current opportunity about IoT. The other one is now IoT can now have a large range of application, way beyond the traditional factories or industrial applications. Just yesterday, I discovered a new IoT object that helps you ensure that your pool chemicals are correct. So if you own a pool, it's like a little shark floating around your pool and measuring all the chemicals of the water and trying to improve the chemicals and how you spend chemicals money to get a proper water. So there's definitely a huge opportunity in very different spaces. But it's kind of complicated to start an IoT project. We have to overcome a lot of challenges to actually being able to do it. So a few of these challenges are inherent to any software or hardware projects, but there is additional challenges when you talk about IoT projects. All the security vulnerabilities during this last few months, we didn't hear about a lot of stories, but just before, like every 2 months, you had a headline about some dishwasher or some toy for children's being hacked somehow, and people being able to access any data or to modify the behavior or some equipment. So security is definitely a hot topic also for IoT. The other big caveats of IoT projects is the network connectivity. You don't have an Internet of Things product without internet. However, you can have a lot of sensor. For example, I will show you a bunch of actual hardware later on, but basically don't have any communication facilities or very narrow communication facilities. They're not able to communicate over Wi-Fi or broadband connection. So it's a challenge in itself. How do you manage, update, secure, and get data from a device that may be able to communicate only for a few seconds each hour? That's kind of a huge challenge as well. A lack of standardization in the industry. You have some protocols about how devices can communicate and interact between each other, but it's at the IoT space level, we don't have so many standardization about protocols. So it could be complicated to like build your own system and then on top of that trying to standardize and integrate with your environment. If you're creating an IoT device that need to get into a specific environment and collaborate and communicate with other devices in the field, it could be quite a challenge as well. And one of the last one is scalability. It could be easy to start an IoT project with like 5 devices, but when you're about to deploy 1 million of devices, how do you handle and secure and update 1 million of devices? How do you get information and correlate information between 1 million of devices? That's definitely a huge challenge as well. But as I said, there is a ton of other challenges around IoT space. But the fact is, you can start your own IoT project within minutes. And I will show you later on during this presentation in, I think, less than 10 minutes, creating an IoT project from scratch. So how to start IoT projects? I will show you 4 different things today. The first is a bit of overview about the ingredients of almost any IoT project. Then how do you pick up the hardware? And I will specifically talk about how you pick hardware for creating a prototype or for creating your first series. I will not go over how to industrialize, how to produce thousands of millions of devices, or how to do hardware design. That's another topic. But basically, what hardware can you like buy right now, this afternoon, and start creating your prototype? Then we will see, and it will be mostly a demo, how you can create your first IoT project without having to code anything or even solder anything. And I think that's really one of the greatest things of all time is we will be able to create, you have an idea, you may be able to create a prototype to test your ideas with a very limited amount of hardware, no coding, and almost doing things in a few days. And the last step is when you've created your first prototype and try to assert that, yeah, you may be interested in creating an actual IoT project, how you can go beyond that, what are the steps you can pursue after having created your own prototype. So let's get started with the ingredients of an IoT project. And there is a ton of ingredients about creating an IoT project. Obviously, the Internet of Things is a hardware piece, so you need some hardware. You also need some network to be connected to internet. You probably need an embedded software, so software that will run on a chip within your object. This object will create or will receive some data, and you need then to use the data somewhere else in your system. And probably your application will need some backend software, or we need like an interface, a user interface as well to communicate with this IoT object and display information to the user. It's almost inexistent that we have a device, an IoT device somewhere without having some kind of UI, so people can look at the data generated by this IoT device. And one of the other ingredients we see in all IoT projects are about servicing. So how do you provision an IoT device? How do you secure it? How do you configure it? How do you update it? If you deploy hundreds of thousands of millions of devices all over, I don't know, a factory, what you can do to actually deploy a new version of the software without having to go on site and to connect any IoT, all the IoT hardware to a PC to update them, and how you decommission IoT as well. So that's a big topic. We will see a few of them in the next slides. So I will talk about the cloud and some of the Azure offerings we have around it. But the biggest question is, why do you need a cloud if you're about to start an IoT project? You can definitely create IoT devices and IoT project without cloud. Sometimes it's a good choice, but it's very limited. Most of the times you will need some form of cloud to be able to create a truly scalable IoT project. But why? The first reason is security. It's very hard to secure devices and without having specific services like Azure Sphere. Azure Sphere is a service that allows you to securely identify any devices, so you're sure that any device that sends you data in is actually your own device and not somebody else's device or hacker device that is trying to mimic your own IoT device to send you wrong informations, but also to secure the device itself. So the device is only receiving information from an authorized server and not any server in the web. The second point is managing diversities. And we have a bunch of axes around IoT diversity. When you create an IoT project, and when you have an IoT project spanning years, it's almost guaranteed that you will have several generation of IoT devices. So maybe you're creating the same IoT device, for the same purpose, but you will change some components in it. You will upgrade the component to the latest available from your manufacturer, bigger processor or better sensors. So, but you still have older devices in the field and still running, and you can replace them, or you can sell to your customer the newly upgraded device each time. So you will need to manage this diversity of devices. You will also need to manage the diversity of connectivities. I will talk a bit more about this later on. So next thing also is integrating all these IoT devices into the existing IT systems. If you're a backend developer, for example, you may want, as a backend developer, create a service that will allow to display something in the IoT device, or to get the data from a specific IoT device, or to maybe reboot a device remotely. So you will need ways to interact with the device while managing diversity and while doing this securely. So IoT gateways, cloud IoT gateways, I will show you one of them later on, are components that allows any kind of developer basically to connect to IoT devices securely and while managing diversity. And the last step is managing, and what I mean by this is all the servicing things. If you're the administrator of your cloud solution, you don't want to create all the identities and to unroll all the devices yourself, because if you have hundreds, thousands, millions of devices, you will not have time to do it. So you will need to delegate this to a technician on the field that will connect and install the devices. But how do you do it in a secure fashion? That's kind of things, that kind of features that are brought to you from a cloud IoT gateway, and that are hard to replicate without a cloud offering. So it was a short introduction to different kinds of ingredients you have on all IoT projects. Our next section is about choosing the hardware, and I will leave you for a few seconds asking yourself, what do you think about? Missing but one. Sorry. When you see all these devices on the screen, which of them are you categorizing as an IoT hardware, an IoT material? So I let you think for a second about this. And so you have, if you don't know, you have a Raspberry Pi at the top, then you have a HoloLens, then you have an Azure Kinect, which is a connected camera with the Kinect sensor in it. You have a phone, you have obviously a drone, and you have it's a Surface laptop, but basically any laptop on number 6. So the fact is, all these devices can be considered IoT devices. So it's one of the things when people think about IoT devices, they are somehow limiting the range of devices they think about. But any devices that can send any form of telemetry can be configured remotely and can have a state and obviously is connected, can be qualified as an IoT device. So even a mobile application somehow sometimes can be qualified as an IoT device and can be connected to IoT gateways as well. So when you want to pick up hardware for creating your IoT project, you have a ton of constraints to think about, but few of them are in this slide. So first one is, do you want a custom-made hardware or do you want a ready-to-use hardware? And I will show you just after the slide, I think, and later on during my demonstration. But today we have a lot of different hardware that you can directly use within your IoT project. So you don't need to start an IoT project by finding somebody who is qualified in electronics and designing your own integrated circuit and so on. The next axis is, oh, sorry, it's still in French. Let me try to update it. No connectivity, no internet. Yep. So here we are, no internet or Ethernet. And this axis is really important, and a lot of devices, the spectrum of devices is literally all over this axis. You have some IoT, you have some sensors that are not able to communicate at all. It's difficult to classify them as an IoT device, but sometimes it's in a disconnected state. But you have a ton of devices who have very low range connectivity, and these devices may not be able to connect to any internet system. For example, if you have a presence detector or temperature sensor in a building, not all of them will directly connect to Wi-Fi. They will connect over a wireless network, specific wireless network, to what we call an IoT gateway, which is a special component that allows communication with child devices. And this IoT gateway is indeed connected to the internet, and it's sending all the data for all the child devices. And of course, you have computers, cell phones, or even boards like the Raspberry Pi that can directly connect to the internet. And last axis is about the power. So some devices have just a small battery in it, and other one are directly plugged into the electricity, and it's most of the time it's related between both of them. So if you want to have a device which is 100% of the time connected to the internet, this device we probably need to have continuous source of energy. But again, when you're placing some temperature sensors in some buildings, most of the time you're embedding an operating power of several years. So within one object, you will put something that need to send data continuously for years. And when you have to do that kind of requirements, most of the time you will have very limited access, very limited connectivity to this device. So let's see a bunch of different hardware you can actually buy yourself and start doing your projects with. Obviously, you can buy a microcontroller. It's kind of cheap. So microcontroller is basically a very small computer. You have RAM, you have CPU, you have a flash memory, so you can store things in it. but it's very, very limited. And most of the time, it's something we keep for other phases of your project. So when your project is actually already almost ready to go to production, you most of the time pick a specific microcontroller and do all the development on it. One of my favorite products is actually the ESP32. So it's a bit more advanced microcontroller. And if you can see my camera, I have one just here. And yes, it's a full-blown computer, CPU, memory, and flash, and Bluetooth and Wi-Fi connectivity, all in this for almost €3. So it's very, very cheap. And you can already do a ton of things. And because it's connected to Wi-Fi and Bluetooth, that's perfect to create most of the IoT devices. So for that one, you will need to be able to solder things, but you can have one for a few more euros or pounds with already a motherboard, soldered to motherboard and ready to use, and you can plug an USB cable here to get them some power. And then you have, when you talk about IoT devices, and if you look around on the internet, you have a lot of projects using the Raspberry Pis. So Raspberry Pis is a bunch of very small pieces. They are much more advanced and much more powerful than the ESP32 and Arduinos. They range between 15 to 75 euros. Depending on the generation, size, and other components. But you can install a full Linux OS or even a full Windows 10 OS on them. So it's quite interesting to do some powerful IoT object, or if you want to have a project around signage, like you need to control a bunch of screens in a public place, for example, you can definitely use the Raspberry Pis. And here at the screen, you have two different Raspberry Pis, and the second one is not very well known. It's that one. It's called the compute module, and the advantage of the second board you have there is this board is treated to be integrated into industrial systems. So it's industrial grade, and you can connect it to a specifically designed motherboard. So you don't have, again, any soldering on or wires to connect the Raspberry Pi to any sensors. You can have everything embedded into one board. So if you're thinking about doing things in the industrial space, it could be quite interesting. But all this hardware are kind of messy, and you will either need to solder things or to have some wires, etc. But the fact is, today we have even off-the-shelf hardware that are really, really great to use. So first one I wanted to recommend you to is the AMIC chip. So the AMIC chip is based on a microprocessor like the ESP32. It's a board, but it's already as integrated. And actually, I will show you my board here. Yep. Yeah. So as you can see, the board is already with an LCD screens. You have two press buttons here and here. You even have an RGB LED here, and you have already a ton of sensors embedded at the bottom. So you have a accelerometer, gyroscope, temperature, humidity sensor, magnetometer. So you can actually, if you want to build a weather station, you have everything you want to do it. And it's fully embedded, is quite small. If you want to compare to my phone, it's quite smaller than my phone. And it's USB, micro USB powered, so it's very easy to design things with this board. and it's quite affordable for 40 euros, around 40 euros. You can have this board shipped to your door. The other product I kind of like is the M5 stack. So the M5 stack is an ESP32 based device, again with Wi-Fi and Bluetooth connectivity. And what I definitely like about this product is actually, so here is one of my M5 stack. And as you can see, there is two ports, red port and a gray port, and you can actually move this port away and connect additional modules in it. For example, this is one of the modules you can connect to, and this module is actually a 4G IoT chip. So if I plug this board in the middle of the two other ones, my M5 stack is now able to communicate directly on 4G. So you have a bunch of sensors in it, and I like it because it's kind of an more industrial system. Like you don't have the chip, you can see the motherboard, etc. You can definitely place this thing somewhere, and there is a battery in it, and there is a ton of modules already. So you can definitely create more complex objects without having to solder anything. And the last one, and I really like the last one, it's an old phone. Yeah, people don't think about it, but most of the people have some sort of older iPhone or older Android phones somewhere, because we got a deal to get a new phone, new generation phone. So we grabbed this deal, and the old phone is sometimes put away somewhere in the house. But if you think about it, a phone has a great screen, has great connectivity with Wi-Fi, Bluetooth, and even 3G, 4G. There is already a bunch of sensors in it, so you can actually, yeah, you can actually prototype a bunch of things with just a phone, or maybe just a phone and an ESP32. For connecting to some sensors, and as I'm an older, I'm still a mobile developer. I tend to use, actually, I tend to use the phones for my first step. When I create a new IoT project, I try to do everything I can with a phone because it's easy to develop on, it's easy to test the application, and then I move over to a more specialized equipment like the M5 stack or the AMIC chip. And when I've created the full-blown prototype in with this equipment, then I go ahead and design my own circuit. But it's just to have the perfect equipment for the job. But I can do all my prototyping with only the first two categories of hardware. So I've already have a few questions here. So first question from Ankit. I hope I pronounced your name correctly. AMIC chip can be used. Does the AMIC chip can be used for industrial purposes, and how reliable and long-lasting it can be? So the AMIC chip is definitely is definitely a prototyping board. Okay. So I would not recommend it in a large-scale production or in industrial system. However, all the components embedded into the AMIC chip can be found in an industrial quality grade. So you can definitely start your prototype with the AMIC chip, and actually the AMIC chip has almost the same API than the ESP32, and the ESP32 is definitely embedded into industrial systems. So again, you can start with the AMIC chip, maybe put some prototypes into soft production to some customer to beta test your product, and then you can build on it even with the same code. Embedded code up to a more industrial grade device. The other issue you will have for an industrial usage is the AMIC chip doesn't have any housing. So you will need to embed via Makeshift into an industrial grade housing to prevent dust, humidity, whatever to come inside the device. I don't get the other question from an anonymous viewer. Can a controller be used? If you want to rephrase your question, I will try to answer it later on. So how to create your own IoT project without actually coding or soldering? So one of the ways you can do it is by using a project called Azure IoT Central. Azure IoT Central is a SaaS offering that allows you to create your own IoT system, connecting and controlling and managing your IoT devices, capturing the telemetry, displaying and querying the telemetry, and even connecting these IoT devices to other applications. So the fact is, IoT Central is Azure IoT Central is actually based on a bunch of different other Azure services, like Azure IoT Hub, Azure Time Series Insights, Azure Event Hubs, etc. I will not go over the underlying services. But it's a great way to get started, and if you want to later on create your own thing, then you can do with basically the same technology and scalability. So I think the best way to do it is actually creating with you an IoT project from scratch. So I will head over to AzureIoTCentral.com. I'm already logged in into my account. And as you can see, I've already an application. I will show you that application later on. The name is intriguing, but there is a very, very great reason about that name. But I will go over and create a new application. As you can see, we already have a bunch of pre-made application for specific industries on retail, energy, government, healthcare. And the cool thing is, if you want to distribute your application to your customers, you can actually build Azure IoT Central application, and then we sell it without the Azure branding to your customers. So that's also a cool way to start a prototype, but even B, start selling your solution to your own customers. So for now, I will go ahead and create a custom application. It will ask me for an application name, so Reactor IoT. Let's see if it's available. Then it asks me for an application template. Again, I will create a custom application from scratch, and then the pricing plan. When you're creating an IoT architecture, it could be really difficult to understand the pricing of things. We made it very simple in Azure IoT Central because you're paying for a fixed price per device per month. I don't know the exact pricing. Actually, I can show you the public pricing. Yeah. Here is it. So it's a few euro cents or British pounds per month per device, and everything is included. Like any querying you want to do over the device data, any upgrade, number of upgrades, etc. Everything is included in this pricing. If you're building your own service around Azure IoT Hub, Time Series Insights, etc., it will be much more complicated to grasp the cost of the solution. I need an Azure subscription to be built with. And I didn't say, but you have a free tier. So if you can get started with a free plan, but it's only 7 days. But if you have only a handful of devices, you can use the standard 1 or 2 plan with 2 free devices. So if you're just developing or testing around the solution, it will be at no cost. Actually, you can even create some applications for your house or things with almost a free tier. And location, I will choose, let's say UK. So I can create, it will provision my application, and setting up all the things I need to connect my devices. So I have a dashboard here. I can customize this dashboard later on, but really the first thing I want to do is to actually connect device to this Azure IoT Central and to start getting some data. So my first reaction would be to go over devices pane and click new device and trying to create by device. But as you can see here in the screen, the template type is unassigned. What does it mean? It means that Azure IoT Central will actually create a device, but there is no way for Azure IoT Central to know how to communicate with this specific device. That's why we need to create a device template before. And basically, a device template is specification, description of the device you want to connect with. So I can go over to device templates and click new device, and I can create one from scratch. So if you're creating your own embedded system or you're using the ESP32 and you want to connect very specific sensors, yeah, you can start and create your own IoT device and connect it to Azure IoT Central. But what I want to do here is to really create simple for my MX chip. And the fact is, there is already a bunch, and I said a bunch, a hundred of devices that are already plug and play with Azure IoT Central, which means I can just go over here and select a device. So, for example, you have dashcam, you have some IoT gateways, you have some other cameras, occupancy sensor, temperature, humidity sensor, etc. And all these devices, you can go away and buy them, and you can connect them to an Azure IoT Central without any coding required, just a simple configuration. And if you go at the bottom of the list, you have here the MX chip IoT dev kit. So I can go on next, create, and now Azure IoT Central knows that I will create different devices that are like the MX chip IoT dev kit. And you can already see a summary of the devices. So basically a summary of all the information that will be collected from the device itself. So I can go on devices and now select my MX chip dev kit. I will leave the default name and click on create. And the next step I need to do is so basically what I've done here is I've created the device, but only on the cloud side. Now I need to somehow get away from my actual MX chip to connect to this specific Azure IoT Central application. So I need to go over and click on connect. And I will have all the connection informations needed, like the ID, scope, and device ID is just a simple way to identify as a device. And then primary key. A primary key is basically a password for this device. How do I configure all this information, or how do I put all this information into the actual MX chip? Actually, you need to reboot the MX chip with configuration system, and this MX chip will beam a specific Wi-Fi, and you need to connect to a specific Wi-Fi, and you will have that UI appear on your screen. So this website is actually hosted within the MX chip itself. And as you can see, you can simply put the Wi-Fi settings, so the MX chip know how to connect to your Wi-Fi, and then you can put the Azure IoT Central settings, the device ID, scope ID, and primary key. And you click on configure device, the device will reboot, and boom, the device will be connected to the system. So I will switch over to my Potato server application to show you what is in real life. Long story short, I had issue with my potatoes, and I wanted to understand why my potatoes were sprouting. So I put some IoT devices around my potatoes to understand what's going on. So hence is the name Potato Server. So here is my chip IoT dev kit connected here, and you can see the pressure, the temperature, and it's already 30 degrees Celsius in my office right now, and this average humidity. So all these information are displayed without, again, having anything to code. But I can do other things as well. I can actually send orders to my MX chip. And for example, I will ask my MX chip to do a countdown. So I will type a number here, I will click run, and actually Azure IoT Central, we send an order, a command to my IoT device, and you will see the display. You can really read it because the camera quality is not good, but you will see my screen changing, and I will hold my hand here, and you will see the countdown going on. So it's actually a two-way communication system. You can get information from the devices, but also send information from the devices. So countdown is not really interesting, but sending some configuration data or rebooting the device remotely can be really interesting in an IoT scenario. The last thing I wanted to show you here is all the telemetry you can actually query. So, for example, here I will do a simple query over, let's say, 10 days of data from a simulated device and from my actual MX chip within my office. So, as you can see, I can query over hours of data almost instantly. It's using a specific type of database. That's why I'm able to have this performance, and I can also do different things like aggregating the data in a specific time interval, or removing some devices if I'm not interested in this one, or even comparing two sensors data on the same graph. So definitely the kind of things you can do pretty quickly, and again, without having to code anything. And if you want to actually get that data out of Azure IoT Central because you need it in a specific applications, you can configure data export. So every telemetry sent to your IoT Central can be redirected to any other application hosted on Azure, or even not hosted on Azure, actually. So it was a short demo about using Azure IoT Central. Before answering to the questions, and you can start to ask a question right now, I will answer them in a minute. So Azure IoT Central can give you some interesting informations right from off-the-shelf devices. So if you're wondering, hey, if I'm measuring this humidity, temperature, or vibrations in this specific area, can I get interesting data to augment this machine, this business, etc.? So to answer that kind of question, as I said, you can do it over less than a day by using off-the-shelf devices and Azure IoT Central. Most of the time, when you know you're onto something, you need to create a more advanced IoT equipment. So you may need to use the ESP32 or the MX chip and actually code on the device to get more precise data or specific data from the device itself. Most of the time, when you need to actually develop for that kind of embedded devices, you will need to use a C or variation of C, C++, or Arduino C. You can do it with Visual Studio Code or free code editor with two extensions, the Azure IoT one and the Arduino extensions one. So you can develop all your embedded code directly from Visual Studio Code. If you're already using Visual Studio, you can also create an embedded project with a partner extension, and you can create C++ projects directly from Visual Studio and even remotely debug on Linux hardware. So you can use Visual Studio Code or Visual Studio to actually code for the device itself. If it happens you're a C# developer, you may need to know that in .NET Core you can actually develop application that will interact with the sensors. So you can deploy .NET Core application on the Raspberry Pi, or even deploy Windows 10 on the Raspberry Pi and still using sensor data. And there is a new project, there is a project quite interesting called the Nano Framework that aims to actually run C# code onto small microcontrollers like the ESP32. I already mentioned the Azure IoT app, and the biggest thing about the Azure IoT app is helps you to manage connectivity and devices. It's using open protocols to communicate with devices like IMQP or MQTT. So actually, if you're using the IoT app to connect to some devices, you can definitely replace it later on, or you can be sure that if your customer is asking about the protocol used to communicate with your device, you have plenty of answers because these protocols are open. It works with a very wide range of devices, from the ESP32, some microcontrollers, up to PC, tablet, and phones. And it can easily integrate into your own applications because we've already built in a few SDKs for different bunch of languages, but allows you to communicate and interact with the Azure IoT app. Another thing which is quite interesting to think about is the data. Let's say, for example, you create a connected camera to detect fires and smoke from video feeds. You don't want to send all the video feeds of your customer up to the internet, up to the cloud, to analyze them, run some AI, to finally send back a message to a building, say, hey, there is fire in room 203. So you will need some kind of AI at the edge, and most of the time you will need some data at the edge as well, and not sending all the data to the cloud, but only sending interesting data to the cloud. That's why we launched Azure SQL Edge, which is a SQL database that's actually run on low power devices like the Raspberry Pi on Linux. If you don't know, we have SQL running on SQL Server running on Linux as well, and you have some streaming analytics capability at the edge. So, for example, if you have a sensor that are sending data every second, but on the cloud side you're only interested in 10-second time span average value, you can actually compute that average locally and within Azure SQL Edge, and send only the interesting data, the average data, onto the cloud or onto your system. Another thing is included to be able to manage a bunch of different databases all around the world to all of your customers. So if you're upgrading the schema database, for example, you can push an update of the schema along your application update quite easily onto all the devices at the same time. So Azure SQL Edge is the idea behind this product is not really to put SQL database into every sensors, but if you have a gateway scenario, so as I said, you have a very small low power devices with sensors, and all the sensors are sending the information back to a single point, a gateway, which is at customer site. Maybe Azure SQL Edge could be interesting at this customer site. And the next area is also integrating with business apps. So, for example, if a specific sensor, let's say your logistic and transportation company, and you want to ensure that the goods you're moving are always below 20 degrees Celsius. So for doing this, you put sensor into the trucks, and if any sensor is going above 20 degrees, you want to send an email to your customer, or to send an email to the driver, that kind of things. So actually, you can integrate Azure IoT Hub or even Azure IoT Central to other services like Logic Apps. Logic Apps allows you to integrate B2B applications and create workflows. So you don't even have to code to create a Logic app. It's just a drag and drop designer, visual designer. And for example, when you have a new event coming from Azure IoT Central or Azure IoT Hub, you can filter it, and depending on conditions, you can do better things like inserting the data into a SQL database, adding a line into an Excel file, or sending an email, that kind of things. You can obviously store all the incoming data from IoT devices to storage, so you can run big data analysis on top of it. Or you can create custom integration through service bus and event hubs. So when a new message is received, is processed by your application if you have very complex business rules. So all of these things, you can do them either with Azure IoT Central or Azure IoT Hub. So yeah, I think today is an exciting time because everyone can start an IoT project with all this equipment and services. And actually, I've myself started a bunch of different projects in different areas and build this project in less than a day to measure if it's interesting to pursue them or it was simply not a good idea. So we have ready-to-use IoT hardware. We have no-code solutions to allow you to get the data from this IoT hardware and integrate it into small application or small workflows. So everything you need to get started is actually some ideas. If you want to learn more about this, we have an entire learning path on Microsoft Learn. Microsoft Learn is a free online learning platform. So we have a bunch of modules to discover Azure IoT Central and other Azure IoT products. And if you want to buy an MX chip and try doing something yourself, I've added the link to a tutorial about how to integrate the MX chip with the Azure IoT Central. So it's basically the demo I've done, explain step by step. And now I will open up the Q&A, and I see I've already have a bunch of questions. So I will try to answer them in the order. Yes, so the slides, I will send the slides as an announcement, so you will have the slides here. Is there a template in Azure IoT Central? Another question from Ankit, thank you. Is there a template in Azure IoT Central for Raspberry Pi 4? Unfortunately, no, because the Raspberry Pi 4 doesn't have any sensors built in, so there is very few data you can send in. However, you can use the Azure IoT Central SDK to simply connect your Raspberry Pi 4, 3B, even the smallest one. I forgot the name. You can connect the Raspberry Pi to Azure IoT Central, but there is no pre-built image on it. Where do you think it's best to acquire the IoT hardware kit? Honestly, I cannot answer to this question. First, because I cannot recommend one supplier, and second one, because it depends on the country you live in. And I suppose that most of the viewers today are from UK, because this event is organized by the Microsoft Reactor London. But I'm in France. I'm based in France, and I don't know any supplier in UK, but it's kind of easy to find them, and there is a I may be able to recommend one of them, which is Seed, SEED. You can search it on the internet because it's one of the biggest supplier of hobbyist IoT kits, and I think they're delivering into UK as well. A question from Per. Is there an easy way to connect an old phone as a device? it depends. If you want to connect it to Azure IoT Central, again, you will same case than the Raspberry Pi. You will have to connect to use the SDK to send some data onto Azure IoT Central. If you want to use Azure IoT Hub, which is the underlying device management and communication service that is used by Azure IoT Central, it's like really easy to use an SDK with a mobile app to connect to Azure IoT Central. It's like adding a package to your application. There is a Cocoa package, there is an Android package, there is a Xamarin package for it, and adding like 2 lines of configuration and your device is connected. But you will have to write code to send actual telemetry data or receive commands and act on these commands. Actually, there is a quick start in Azure. Let me search for it. Azure IoT Hub quick start. Yeah, found it. So there is actually a lot of quick starts about sending telemetry from a device to an IoT hub and with it with backend application. This page in .NET, I will send you the link as an answer to your message. But there is a bunch of other languages, including Android and iOS native frameworks. So another question from Anket, and do not hesitate. We still have a few minutes, so if you have a question now, just send them right now, so I will have the time to answer them. Another question from Anket. Sensors are available in many prototype boards, but generally they do not provide 3G, 4G connectivity. MX chip is not doing it. Arduino, Raspberry Pi, which is a chip. What is your cheapest suggestion on connecting those to Azure over 2G, 3G, 4G? You tried few 2G boards and had issue connecting it to internet using AT commands. And I feel your pain, Anket. You're right. So there is some boards, so like this one. Actually, I will try to show you on the camera. Yep. So this board is an ESP32, but with a SIME 800L module, which is an Ethernet module. You can see the 2G antenna here, and I have my SIM card just here. So in this single board, I have Wi-Fi, Bluetooth, and internet connectivity to 2G, 3G. The only way to communicate with these components is again using AT commands. However, there is some libraries. Let me try to find it again. There are some libraries that actually allows you to using IMQP SIM and 800, that allows you basically to connect to Azure IoT Hub through IMQP without having to deal with AT commands. So that will be my recommendation here. It's tiny GSM, yeah. So it's tiny GSM library that allows you to basically. There is another one. I don't remember the name. There is 2 of them. Oh, MQTT. Sorry, it wasn't IMQP. It is a MQTT. I'm sending the link right now to the library. So yeah, that's and even simple HTTP client. So it's working on a wide range of modules, and that would be my recommended go-to to get that connectivity over to from your device. It's one for Arduino. I don't know if there is one for Raspberry Pi, for example. My other recommendation would be simply to I've created an IoT device for my grandmother, and actually I've used a 3G hotspot just plug behind the device. It was very dirty, but that it works. The other thing you need is to actually have an IoT SIM card, which is actually a SIM card you pay either per month or per megabyte. So there is different operators around the corner. I can talk about Twilio. Twilio, which is a SMS gateway provider, is also providing IoT SIM cards. I haven't tested them. I've tested personally Things Mobile, a company from Italy, and One OT from Central Eastern Europe, but both provides IoT SIM cards easy. And I have another questions, and I will the last question from Anonymous. I don't really get the question, and we reach the end of the stream. So if you have any other questions, please reach me on Twitter at Simano. You have the links here for getting the slides. You also have my Twitter account at the beginning of the slides, and I think it's just have a small survey. Thank you for attending this session. I hope you enjoyed it and learned new things, and I hope you're already thinking about doing some IoT stuff. Please take a minute to complete this short survey. I wish you a very pleasant afternoon, and again, if you have any question, reach me on Twitter. Thank you.